Excellent. You're getting the hang that all acids and bases are solutions of ionic compounds, one that has H or OH in it. Let's talk about concentrations then of the H part or the OH part, okay, and then why we have to come up with some way to mention those that aren't inconvenient. Molarity of something is what we've been studying, is how we measure solutions concentration. The more moles you have per liter, then the stronger the solution is. Now, the molarity of the hydrogen is what we're mostly interested in. We're going to use a different symbol instead of saying the molarity, big M, of some compound. We're just going to put square brackets around it. I don't know who made that up, but that's putting these square brackets around it means what's the molarity of what's inside. So the molarity of hydrogen can go from about 18 moles per liter is the strongest, like battery acid. That's bad stuff. All the way down to a billionth, even a trillionth of hydrogen. So that has no hydrogen in it. And so that's a large range, and it's inconvenient to work with. So we're going to come up instead of using the logarithm. Logarithm is just what power do you raise 10 to equal that concentration. 10 to what power gives you the concentration. It's the exponent. Exponents and logarithms are the same thing, if you remember from math. So here, I'm going to take whatever the molarity is of your hydrogen, and we've been getting practice with that, and we're going to see what the log is. A log of 10 is a 1. What do you raise 10 to get to 10? 10 to the 1 equals that concentration. So then you guys still throw the negative on it, because most of the numbers for acid concentrations are down here in the decimal ranges, so it's more convenient to have positive numbers down there. But a log of -1, the higher the number to the left of the number line, is actually better. -1 is actually a very high pH. Okay, where do I have to move this decimal? How many places? What do I raise 10 to get to 0.01? Got to move the decimal over 2. That's going to make it 10 to the -2, in other words. That's what 0.01 is, 10 to the -2. So the exponent on 10 is -2. I put a negative in front of it, and the pH becomes 2. Now, I've arranged the problem so that you hopefully can see what I'm talking about. How many places do you move the decimal over to get it behind the first number? That number is usually what the pH is. But if you crank it out on your calculator, you may start to see what I'm getting at. pHs range from 1 to 14. In other words, 10 to the first hydrogen molarity, 10 to the -7th. Remember, the minus always has to go in here. 10 to the -7th, that's 10 millionths of a mole per liter. And 10 to the -14th, which is, I think, 10 trillionth of a mole per liter. So 1, 2, 3, 4 through 7, anything below 7 is considered acidic. Anything about 3 or better is strongly acidic. Okay, 7 to 14 is basic, and anything above 10 is really strongly basic. Okay, so let's take a look for some examples on your worksheet. And then I want to mention one last thing about the concentrations, okay? So I'm going to let you do the first few problems, then you can come to the next video to see how OH and H are related.